So in the last lecture, what we had was statistics part one, basics part one. So we understood what different kind of statistics are available. Statistics itself is divided into many branches. So we studied like which are major branches, which useful to us. We didn't study statistics branches from a theoretical point of view. From a practice point of view, as a practitioner, as a data science practitioner, what statistical branches we should know. So we studied descriptive statistics, inferential statistics, predictive statistics, prescriptive statistics. So we studied all of that. We saw a lot of examples on that. Okay. So I think if you are thinking that you are not able to remember, then you need to see the PPT, whole PPT. Okay. So today we will have some more, we'll get advanced, like we'll get advanced and we'll learn some concepts in statistics. Like we are now getting into statistics. Right now we were looking statistics from 50,000 above, 50,000 feet above. Now we are getting into statistics. And slowly we are getting into statistics. So these are the things I have planned for next couple of lectures. See, very interesting. Mean, expected value, median, mode, mean, max, standard deviation. Many of these things, this kurtosis and skewness, like we will now get into more detail and we'll get into formulas and all. Variance, continuous variable variance, covariance, correlation. These are all basic concepts you see. Interpretation of confidence interval, interpretation of credible interval, and then point estimate, interval estimate. So all these things are very basic things. Okay. So now we'll study one by one. And there are many measures to measure same thing. So to measure same thing, central tendency, we have three measures: mean, median, and mode. So we have to see under what condition we have to use what. When to use mean, when to use median, when to use mode. So what is the, suppose I give you mean of some, so there is a data variable, okay, data column in Excel, and in that suppose there are 20 entries. So if your assistant comes to you that mean of this data is mean if this data is 35. There is no unit, so only 35. So does that 35 has any meaning? It doesn't has any meaning because you have to see the range also. You have to see the dispersion along with it. Then only your mean will make a meaning. Suppose in that 35, one value is 0.02 and one value is 45. Your dispersion is too much. Then yes, the mean doesn't have any meaning. Mean has a meaning only when the variation is very less in data. Like values are nearby to each other and variation, there are no outliers. Then only there is a meaning of meaning. Then only mean has some meaning. Because if outliers are more towards, support outlier is more towards the lower side, your mean will have value towards the lower side. And if your outside will outlier is towards higher side, mean value will go towards that higher side value. So it doesn't truly represent the data, mean. So in such a case, where we have outliers, then we use median. Okay, we don't use mean. Then median has more meaning. Okay, so now we have understood which condition we have to use mean, which condition you have to use mean. So suppose you are going to your boss and you are going with the mean value of this column. So you should never go with mean value. You should always go with the mean value of the column, then maximum, minimum, range, and standard deviation. These values minimum you should show about a data column to your boss. Or if your assistant is coming to you, you should teach him that I want minimum any data column, mean is not meaningful. I want maximum, minimum, range, and standard deviation along with mean. Then only mean will make any meaning. So like that, this practice you have to develop, okay? So we'll try to study all of this Today it may not be possible, but a couple of lectures or next lecture we'll finish it. So this is nothing but your statistics part 2, and in some part in your life, in your courses, in your engineering, in your 12th standard, your high school, you have studied many of these concepts. Not all of these, but see, this 7, 8, 9, 10 on the right hand side you might have not studied, like what is confidence interval, what is credible interval, point estimate interval. So these things are new. But apart from these, all the left hand side column until 6 in the right hand side column, correlation, you have studied some of the other point. But there is some dust which has deposited on this, and many of these concepts you are not forgotten, but they are blur in your mind. So with these lectures, my aim is to make them crystal clear. That this concept should be crystal clear to you. And when to use what measure? There are many measures. So when to use what measure? That we should know actually as a statistician. Then only there is a meaning of knowing these things. Otherwise, what is knowing on mean, what is median, what is mode, not meaningful. When to use what? Now you have understood that mean is useful only when there are no outliers in the data. If there are outliers, then I never go for mean, I go for median. Then it makes more sense. And if there are outliers, we go for median plus quartile. Quartile like first quartile, second quartile, third quartile. Those values are meaningful when we have outliers in the data. Okay, so all these concepts in some other point in some form we have already discussed in previous lectures. So we'll repeat some of. So now you see this central tendency. So central tendency means like there are 21, suppose there are 21 entries in a column, data set column. So like we are more concerned about the central values, like 21 means 11th value or mean average of that or the mode of that. So around center point of data, we are more concerned. So this is called center tendency. So this you can see mean. So mean also we have 3: arithmetic mean, geometric mean, and harmonic mean. So arithmetic mean everyone knows, and geometric mean and harmonic mean couple of times I had suggested you to Google it out and study for yourself, because these concepts I am not teaching, but you have already learned these concepts in your maybe 10th, 11th class, or maybe I think so. So what is the geometric mean? What is the harmonic mean? If you are not done so far, so I will again suggest you to write down these things and Google for yourself. Arithmetic mean, I think I need not explain. Now positional average. So one is mathematical average. So mathematical average is nothing but your arithmetic mean, geometric mean, and harmonic mean. So they are mathematical average. You have to use some mathematical formula to calculate it. So that's why they are called mathematical average. Now positional average. Now median and mode. So median and mode are positional average. To calculate median, you don't need any formula. To calculate median, suppose there are 21 entries in a column, data column. What you have to do to find out mode? Just increase them, like put them in ascending order. You have to put them ascending order. And suppose there are 21 entries, 11 and 11th entry will be your mode. So you don't need any formula to calculate them. So that is position. Position means middle value. Middle value of that column is mode. So that is positional. Based on position. Middle position is called median. So similarly mode. So most frequently occurring value is called like it is mainly used for your nominal or categorical type of data. Okay, so these two type of meanings we should be able to differentiate. Central tendency measures, either they are calculated by mathematical formula or they are found out based on position. Now, mean, median, mode, I think I'm not going through this slide. Now there is one more important concept here, which is something important, very important, and might be new to the people who are not from maths background. So what is expected value? So expected value is another name given to mean. Mean average, mathematical average. So expected value is a statistical name given to mean. So how it is calculated? See the right hand side. Don't see the formula. See the right hand side. Suppose this column is given, first column is value, second column is probability. Right hand side, table. Value is 1 and 2. So one can be anything, 1 kg, 2 kg. So it is 1 kg, 2 kg. Getting of 1 kg is 0.4 and getting 2 kg is 0.6 probability. So how to calculate expected value? Simple. See the formula. 1 into 0.4 plus 2 into 0.6. So the value into its probability. That's how you multiply. So you get 1 into 0.4. You see the below, it is calculated here. 1 into 0.4 plus 2 into 0.6. The value comes 1.6. So expected value is it is a equivalent of mean value. So where it is useful, I'll tell you later. I'll give you some business example also where it is useful. So expected value, like I found out by this way. So can it be negative, guys? Can expected value be negative?
No.
No.
No, sir.
Any other answer, Sarthak? Can expected value be negative?
No, sir.
No, you are not right. See, my value column, it can be either positive or negative. Any value it can be, positive or negative value. My probability will be always between 0 and 1 and positive value. Okay. But the value column can either be positive or negative. If it is negative, and if it is a big negative number, addition will be negative. Right? So expected value can be either positive, can be 0 also, and can be negative also. Anything it can be. It's a simple average. Simple average. So average, if you are taking average of negative numbers, it will be negative. If you are taking some positive and negative numbers which are equal, the average will be 0. Like that it is. So expected value can be 0, it can be positive, it can go up to infinity, and it can positive infinity, it can go up to negative infinity. Okay, so now the formula you see on the left hand side. The formula sigma, don't worry. If you see sigma symbol, it is nothing but summation 1 to n. N is equal to 1 to all the values. Suppose there are n values in this right hand side value column, and the probability is given for n values. So I'll multiply all the values with their respective probability, add up all the n values, so it will be my negative value. So sigma is nothing but summation. So what is the formula? Xi into Pi, Pxi. So Xi means probability value, actual value, and the probability of that value. Right now, simple formula X. So just calculation also I showed, right? So value is 1, probability is 4. So I multiply 1 into 0.4. Value is 2, probability is 0.6. So I multiply 2 into 0.6 and I add up. I get 1.6. So that is the formula which is given in mathematical terms in the left hand side. That much is understood, right? Guys, any problem in that, guys?
Sir, this value, this probability I understood, sir, even the formula I understood. But when we say value, so
I'm giving you business example. I'm giving you business example.
Okay, sir.
Right now, I know you have not understood why we have to calculate this new thing. Okay. So this question should come to your mind, and it should come to your mind. So I'll give you a business example. Okay, now next one more example I am giving. Value is 1, 2, 3. Value is 1, 2, 3. Probability of 1 is 0.3. Probability of 2 is 0.5. And probability of 3 is 0.2. See, you add up the probability total. 0.3 plus 0.5 plus 0.2 equal to 1. Total probability is 1. So, how to calculate expected value? 1 into 0.3, 2 into 0.5, and 3 into 0.2. Now, value is 1.9. Same thing. Anna? So, now here, now this is for a discrete function. This function is discrete because x is discrete. 1, 2, 3 are discrete values. Discrete means no decimal point. It is discrete value. Okay, no? Between 1 to 10, there are only 10 discrete values. But there are infinite continuous values. Continuous value means with decimal point. So between 1 to 10, there are infinite continuous numbers. but discrete numbers are only 10, 1 to 10. How continuous numbers are infinite? 1.1, 1.2, 1.3, 1.22, 1.02. Like I can have any decimal number. So infinite numbers, 2.02, 5.02, and then for 9.9, 9.09, like I can have any decimal number. So continuous number between 1 to 10 are infinite. But discrete numbers are only 10. Understand? Okay. So this I am revising. So now this is for discrete values. So X is discrete here. 1, 2, 3. So discrete is very simple. Multiplied by respective probability and you get it. Now, suppose if X is a continuous number. Suppose X is continuous means you see the right hand side plot. Instead of X being a discrete number, we are given its a formula of straight line that X, if you want to find out the value of X, it is given by this formula of straight line. So formula of straight line is nothing but a continuous number. Okay, so Fx. We know that continuous PDF and PMF we have studied in detail. Okay, so PDF is applicable for discrete and no, PDF is applicable for continuous and PMF probability mass function. Probability mass function is applicable for discrete and probability density function is applicable for continuous number. So this Fx is nothing but your PDF, probability density function. It's a continuous number. I'll give you a numerical example, then it will be clear. So then in that case, you have to use, instead of summation, you have to use integration. Integration x limit x minimum to x maximum x into Fx dx. You have to give integration you have to use. So how? Now let us see the one formula here. I have some handwritten things which I just took the image and see. See the left hand side first. The probability density function is represented, Fx is represented by equation of line, simple equation of line. Y is equal to mx. So 0.03125 into x. So simple continuous number 0.03125x. Suppose you have to find the value of function at any point x. You have to put the value of x here in this function. So at x equal to 0.1, just put x equal to 0.1. X equal to 0.2, just put x equal to 0.2. So you will get the value of function, PDF. Okay. So now you have to find the expected value. So how to find expected value? Expected value formula is x Fx dx. So you have to multiply that function by x and take the function itself and then integrate, right? So now, so you have to find out between 0 and 8. So lower limit is 0, upper limit is 8. So just you see the top x, you take an x, then Fx. Fx is nothing but 0.03125x. That is Fx. And then you have to integrate it. So integration of x cube. So integration of it will become x square, right? Here in the before dx, between integration sign and dx, it will become 0.03125x square. So integration of x square, if you little bit revise your integral, will be x cube by 3. X cube by 3. Integration of x square is nothing but x cube by 3. So that much integration you should revise from your 12th class mathematics. So it will be x cube by 3. So now x cube by 3 we got and 0.03125 will remain as it is. So now what we have to do? Lower limit is 0, upper limit is 8. So what we have to do? We have to first put upper limit. So you see we have put upper limit of x. So x equal to 0.8 we have to put. X equal to 8 we have to put. So see we have put here 0.03125 8 cube. 8 means x value is 8. So 8 cube by 3. That is what is first. Then minus you have to put a value of x as 0. So what if I put a value of x in this ex expression of ex 0.03125 x cube by 3. If I put the value of x, what will be the value of ex? X equal to 0 if I put, what will be the value of ex, guys? If I put x equal to 0 in this formula, See, you see, formula is there in front of you. 0.03125 x cube by 3. I'm asking a simple question. I'm putting x equal to 0. What will be the value of Ex, guys?
0.
0, right? Very simple. So that's why minus we are not taking, because minus will be 0. So it will be simple. 0.03125 x cube means x 8 cube upon 3. So value is coming 5.33. So now what we have learned? Two things. We have learned two things. How to calculate the expected value Ex for a discrete variable and how to calculate Ex for a continuous variable. Now this function fx, right now we have that fx as very simple function 0.03125x, but it can be anything. It can be 0.02 sin x, it can be 0.02 sin square x plus cos square x, it can be 0.02 10x, it can be anything, continuous function. Okay, so that continuous function we have to integrate. And for that, you need little bit brush up of class 12th integration formulas. Okay, so right now it was very simple integration. So in integral of x square we wanted to do, so it will be simple x cube by 3. So how it is calculated? Integral of x square means increase the power of x square by 1 and divide the same power by divide it by same power. So x square. So if we increase by 1, so it will be s cube. So s cube and we have to divide by same power. So s cube by 3. So simple formula you have to revise the integral. You should not worry things. You should see where I am weak, what I don't know, and those things you have to go back and revise. You should not worry things. That integration is tough. I don't know integral. Nobody knows integral after 15 years. People will forget, guys. So you have to revise your 12th class mathematics. Don't worry. You don't worry. You should not worry with that. You should not worry the subject. You have studied it, you have passed your 12th class. Every one of you might have got 70-80% in the class minimum. Some of you might have got even 90% in 12th class. So without knowing integral, you cannot get 90% in maths. So you go back and revise integral. So simple integration you should be able to do. Okay, so now we know how to calculate Ex for continuous variable, how to calculate Ex for discrete variable. Guys, any problem in this? Jignesh, Sarthak, Amit, Gajendra.
No,
Any problem till now?
No, sir.
No.
No,
Now,
sir.
next question you should ask me, why should I calculate Ex? What this bloody thing means in business? Why should I calculate Ex at all? Like, why should I calculate expected value? That is one thing that you should ask me now. So next we are going to address that. Okay. Now take a simple example. So I told already that expected value can be positive, 0 or negative. We already discussed that. So there is the example of negative value here so that you can see. So here x is -1 and -2. So both probability is 0.5, 0.5. So -1 into 0.5 plus -2 into 0.5. So it will be -1.5, right? So like that, expected value can be either 0, it can be positive, or it can be negative. It can be any number. So we should know what is the significance of these positive. If expected value is positive, what is the significance? If expected value is 0, what is the significance? But significance means business significance. If expected value is negative, what is the significance? So I will give you one example. See, how many of guys you deal with lotteries, guys? How many of you buy lotteries? Amit Parik to jarur kharidta hoga lottery hai.
Yes, sir. I bought so many times, but not now.
Yeah, so Pandya ji, aap nahi kharidte lottery?
जब मैं सर सेकेंडरी में
Okay, so in some time of your time you have purchased lottery in your life, right? Jignesh and Amit, it is true that some point in the time, couple of times you have purchased lotteries. True, right? Now, I have a question here. It's an American example. Lottery ticket cost is $10. Lottery ticket cost is $10. And winning amount that you can win is $10 million. $10 million you can win. And only one ticket cost is $10. And how much is the probability of win? 0.601. That is the probability of winning, right? Because they are selling $10 ticket to millions of people, right? So your probability of winning is very less. You agree with that, guys?
Agree, sir.
And how you calculate the probability of winning? See, you have to see like how many people it is being sold. If it is sold to 10 million people or 20 million people, your probability of winning is even less. Okay, so
Yes.
probability of winning is 0.601. So that is very less. Now you have to find out whether I should buy a lottery ticket or not. Now tell me, guys, without reading this, tell me, is there any way to find out whether I should buy a lottery ticket or not? Tell me, guys. Is there any way, any scientific method to find out whether I should buy this lottery ticket under this condition? The ticket cost is 10, winning probability is 0.601, and I can win $10 million. Is there any analysis or any maths or anything which you have seen so far to answer the question? To my question is whether I should go for this $10 ticket or not. Is any analysis? Have you seen any? Have you heard any time, guys? Jignesh bhai?
Yeah.
No, sir, not like exactly, but there are some number-based trend at that time we are following.
That is all numerology, Anna. That all is, there is no scientific basis for that. They are all heuristic. Heuristic, you understand, na? Rule of thumb.
Yes,
Some number-based,
yes,
some
yes.
rule of thumbs are there. No scientific basis.
Yeah.
So now today I am telling you scientific
No.
basis. Okay.
Wow.
So tell it is. See, without using expected value, it is nearly impossible question to evaluate. You want to say whether buying $10 lottery is a like a good game, good investment or not, or should I just go for some ice cream for $10? Okay, so you want to, so expected value helps you. Now, how to see? Now, what is the expected value of this game? Guys, what is the expected value of this game? Probability into the value. Probability is 0.601. Probability and value is $10 million. So that is the expected value of this game. That is what XEX, right? X is $10 million and probability is 0.601. So I find out the expected value. See the third bullet. I multiplied 0.601 with $10 million. $10 million means there will be 6 zeros after 10. So I multiply this. So I'm getting how much? 1. I'm getting one answer. If you multiply 0.601 with $10 million, answer will be 1. Answer will be 1 means average will be 1. That is your profit. That is kind of your advantage. So your advantage is only $1. And how much you are spending? $10. So how much is this game? 1 minus 10 minus 9. So expected value is negative. Expected value is negative means you should never buy this lottery. In buying itself, you are losing $9. You are expected to win only $1. Chance of winning is only very less. So expected value is negative. Expected value is very less, $1. And total C, cost of ticket is $10. So how much you are losing? 1 minus 10, $9 you are losing. So you are losing in this game. So last bullet you try to read now. This is true in most lotteries in real life. All lotteries are like that in real life. Buying a lottery ticket is just an example of our bias towards excessive optimism. It's a state of mind that I may win and I may become millionaire. It's just a state of mind. But most of the time you are going to lose. Only one person will win And that also we don't know whether that person will be kind of their own person or their own relative or something. We don't know all these things. Okay. So it is always buying lottery is always kind of. So how you did? First you find out the expected value. Expected value is $1. And you are spending $10. How is the game? 1 minus 10 minus 9. So you are losing in this game. Okay. So suppose expected value is $12 and you are spending $10. Then still expected value is positive. Then still you can go for that game. So now you can calculate to make expected value $12, how much should be the probability of win? That you can calculate from this. To make expected value as $12, what should be the probability? That will never be, because they are selling to so many million people. He is not selling to some 1,000 people. He is selling this lottery ticket to millions of people. And whatever $10 million he is giving you, he is making out of your money only. First, he will sell all the lottery tickets, and he calculates that if I sell all my lottery tickets, I may make 13 or 14 or $15 million. He will make that much money. And from that money, he will give you $10 million as award. So he will not sell to 10,000 people. If any lottery is sold to very few people, the cost of that lottery will be 1,000 rupees, $1,000. It will not be $10. If he is selling only to 10,000 people, he will not keep it ticket so low. He will keep ticket as $1,000. So it is that game here. So suppose expected value in a game is positive, coming positive, then it is a profit game. If it is coming negative, it's a loss game. If it is zero, then it's a neutral game. So that is the business significance of expected value. See your this roulette wheel, you know, right? Roulette wheel, have you heard of this roulette wheel, guys? Have you seen? You have seen in TV that roulette wheel? Some of you might have gone to Goa and played those kind of wheels. Goa, those wheels are legal. So these casinos are legal in Goa. So you can go and play some money, put some money on that wheel. So overall, if you calculate expected value, so how I am taught the expected value. They gave me example of roulette wheel. And they showed me that if you roulette wheel game, expected value is always negative. Expected value is negative means you are always going to lose. Most of the time you are going to lose. So expected value is negative means who is going to win? The casino is going to win. If expected value is positive, then you have more chances of winning. Casino will lose. Okay, so roulette wheel will be designed always in such a way that expected value will come out to be negative. Always, roulette wheel who designs? Casino designs, right? He will always put design in such a way that expected value is negative. That's how they design it. They design it by calculating expected value. So negative expected value, roulette wheel game, if you calculate the expected value, it is always negative. So you are always going to lose. So that's how they design it. So meaning of expected value now you understood. If in some game expected value is positive, then it is good for you. You have chance of winning. You are going to get profit. If it is neutral, it is neutral. If it is negative, you are going to lose. Okay. So that is some expected, and there are so many other applications of expected value. So today we completed one concept. We calculated expected value for discrete variables. We learned how to calculate expected value for continuous variables. We learned what is the physical significance or business significance of expected value. Till this point, any questions, guys? Till this point, any question?
No, sir.
Anything, but your voice is coming very low. Sarthak, any question, or Amit Parik? Any question till this point?
No, sir.
No, sir.
Is it understood properly?
This is understood, sir. Only the extension of the information which I wanted to ask you. That
Yeah.
let's say, I mean, how many people bought the ticket? I mean, this is data
They
related.
won't tell
most
you.
of
They
the
won't
time.
tell you.
No. But I mean, in everywhere, if we have to calculate the expected value, we need to get that data. Na? Based on that only, it
No,
will be
no.
calculated.
Why you need expected data? Yeah. Yeah,
So,
you should know the
sir,
probability
in
of winning. You
Yeah.
should know the probability of winning.
Yes.
For that you should know. For that you should know how many people they have sold the ticket.
Yeah.
Okay, you will not know it, but suppose it's just an example. Yeah, there will be
Yes,
many
yes, sir,
business.
understood.
There will be many business situations where you will know the probability and the value also.
Correct.
Like you will know, right? Like roulette wheel. Roulette wheel example I can show you, but I am not included in my lecture today. But if you see roulette wheel, expected value of roulette wheel, if you find out little bit in Google, you will get that example. Then you will find that it is very easy to calculate the probability of winning in roulette wheel. And how much money you are putting, that also you know. So both you know, probability also you know, and value, how much you are going to win, that also you know. So you can calculate expected value. Roulette wheel, it is easy to calculate probability of win. So there are two kind of roulette wheels generally. One is European, one is American. So there is a minor difference actually, that one is having zero, only zero, and another is having two things, 0 and 0. So in one roulette wheel, probability of winning is more, and in one roulette wheel, probability of winning is more, even less. So one European roulette wheel. So which is European and which is American exactly, I don't remember. They are standard actually. Roulette wheels are standard. Digits in that and zero, those things are standard in that. They are not from casino to casino, they don't vary. Roulette wheel is always standard. So you can find out your probability of winning. Just try to search Google probability expected value in case of roulette wheel game. You try to find out in Google, you will get some nice examples. So Gajendra, any questions till now?
No, sir, but I have one query that here like dollar, $10 and value is the 10 million, right? Probability is the 0.60 and value is $10 million, right?
Yeah.
Like in lottery. But here we
Yeah.
know that $10 million is the expectation, right? And they will sell to
Yeah.
10. But
Yeah.
where we don't know, then there we can't calculate the expected, or we have to assume.
No,
right?
in dollar, any lottery, they will tell you the how much amount you are going to win. That you will know. But your probability of win, nobody will tell you.
Yeah.
Got it, na? Because
yeah,
see, when you purchase lottery, you know it is whether it is a 1 crore lottery or 10 lakh lottery.
Yeah,
So
that.
winning amount you already know.
Yeah.
But nobody will tell you the probability of winning. If they
Yeah.
put probability of winning like this 0.601, nobody will purchase.
Yeah. So yeah, so if there is a continuously, like if there is a target that they will change to 10 million people, right? This is a
Yeah.
target. Then they will then they will announce the price. But some place where target is not defined, there we can calculate the expected value using the continuously expectation or not.
No. In lottery, it is impossible to find. You cannot find the probability. They will know. They will know because they know how many people they are selling. We don't know how many people they are selling.
Because they will announce the price. Okay.
They will know. They will know how many people they are selling.
Yeah, they will know.
We will not know. They will never tell us.
Yeah, in that case, otherwise we have to assume
Yeah,
that
we have to assume only. We have to assume only.
Okay.
So in that case, assumption only we have to take.
Okay.
Okay, guys.
Okay.
So, and see now, median. Now mean and expected value. Both are related concepts, so we have covered them. And now we are going to median. So median also we have covered many times. So see here. This formula you try to see. Don't worry about formula. I'll give you an example. I'm giving you only 4 numbers. 5 numbers. 1, 2, 3, 4, 5. What is the median? Tell me, guys. 1, 2, 3, 4, 5, only 5 numbers. And they are arranged in ascending order. 1, 2, 3. 3 is median. Now I give you, add one more number. 1, 2, 3, 4, 5, 6. What is the median?
3.5.
Huh?
3.5.
How you got it?
6 plus 1 divided by 2.
No. Wrong.
Maximum number of number of count like 6.
No. Correct, not correct.
Sir, 3 plus 4 divided by 2.
3 plus 4 divided by 2. Yeah. So it will be 7 divided by 2. So it will be around same number, 3.5. But the formula is the middle two number you have to add. See, I'll give you one example. Don't see this formula. See here, example is given. So suppose number there are 9 numbers. So 9 is an odd number, right? 1, 3, 3, 6, 7, 8, 9. So these 9 numbers. So there are 1, 2, 2, 6, and 3, 2, 2, 4, and 6. 7 numbers are there. 1, 3, 3, 6, 7. So in that case, you have to arrange them in a increasing order. So you have done that. 1, 3, 3, 6, 7, 8, 9. So 6 is the middle number because number is odd. Now you have below, you see the example. How many are there? 3, 3, 6 plus 8. 8 numbers are there, right? Number is 8. So 1, 2, 3, 4, 5, 6, 8, 9. So there are total 8 numbers. So that is even number. So how to calculate it? Middle two numbers you have to take. 4 plus 5 divided by 2. Got it, Jignesh? Got it, Gajendra?
Sir, even in this case,
Yes, sir.
if I add this 8 plus 1 and then divided by 2, it was 4.5.
That is just a coincidence, man.
Yeah,
That is just a coincidence.
Yeah, so my middle case.
Like that, many numbers you can combine and divide by something, you will get 4.5. That is just a coincidence. But actual formula is middle two numbers you have to add, divide by 2. If the number of numbers are even. If odd number is there is no need to calculate. Numbers are odd, middle number is already there. So that is your median. So now you know how to calculate median. Gajendra, you got it?
Yes, sir.
Jignesh, Sarkar, Amit.
Yes, sir.
Yes, sir.
So now it is clear. So median and mode. So mode, guys, can you tell me mode? I'll give you one example. Now see here. First one, 3, 4, 5, 5, 6, 6, 7, 8, 8, 9, 9. What is the mode? First one. 666. No, mode is 6.
6.
Mode is 6, not 666. Mode is 6. Now see the second one.
Sorry, 6.
Now see the second one. 3, 4, 5 is there 3 times, 6 is there 3 times, 8 is there 2 times, then 99. What is the mode? There will be 2 mode values. 5 also 3 times and 6 also 3 times. So 5 and 6. So that is very important. Nobody might have taught you so far that there can be 2 mode values. So here mode values are 2, 5 and 6 both. Both are mode here. Because both are repeated 3 times. Okay. Now see the last one. Last one, nothing is repeated. Last one, nothing is repeated. So there is no mode. Got it, guys?
Sir, for the last one, there is no mode, or there are 11 modes.
No mode. You cannot say 11 modes.
Okay.
No mode. Nothing is repeated, no. All are unique numbers.
Yes, sir.
So see, one mode is called unimodal. 2 nodes are called bimodal. And there are more nodes like that. Suppose 555, 666, like 555, 666, and 777 is also there. So mode will be 3, 5, 6, and 7. So that is called tri-mode or whatever you call. So it is multimodal. So modes can be any number of that. Either highest number. So highest number means it is undisputed mode. If something is repeated highest number of time, so there is no dispute, that will be mode. But there will be many numbers which are repeated same number of times. If there are many numbers which are repeated same number of times, so all will be modes. So modes can be anything. 100 modes, 10 modes, 15 modes. Got it? Got it, Gajendra?
Yes, sir.
Jignesh, Amit? Got
Yes,
it?
sir.
So this
Yes,
is
sir,
about
clear.
mode here. So now we'll take a couple of examples now. So mode there are, try to read with me. Important of set of observers. So we are comparing now two things, mean and mode. So first of all, see mean. So mean means all data is of equal importance. I already told you there should not be any outliers. If outliers are there, if range is high, range means maximum minus minimum. If that is high, there is no meaning of mode. There is no meaning of average or average of meaning or mean. Mean as average is no meaning if there are outliers. Range is high. If range is high, then you come to right hand side. You go for median. Median mean is affected by outliers. You know that mean is affected by outliers, and median is not affected by outliers. Now see the application both application of both. So application means you try to read with me the second line now, second row. Mean, about mean we are reading, yields best representation of average when each value is important and there is less variation in observed values. Means suppose I have 20 entries, 20 entries are equally important. I cannot discard anything. And there is very less variation. Suppose there are 20 numbers. So my numbers are either varying between 11 to 15, 11 to 16. My numbers are not varying from 11 to 1000. If they vary from 11 to 1000 means 11 also outlier, 1000 also outlier. Then I have to go for median. Got it? Then you read this in median last column. Median, you read the second one. Median yields best representation of average when few are too low and are too high. If there are outliers, then median is the best representation. If there are no outliers, all values are equally important, then mean is out. Mean is. So that's why I told you when starting the lecture itself, if somebody is coming with you with median or mode, you should always ask for maximum and minimum value and standard deviation. Without that, don't accept mean. Mean doesn't have any meaning if you don't have maximum, minimum, or standard deviation. If standard deviation is very less and mean minus maximum is not much, then only your mean is meaningful. Then only it represents the true average. But if there are a lot of variation, there is a lot of standard deviation, then mode better represents the average. Got it, guys? In which condition you have to use what? Ajendra?
Yes, sir.
Any Sarthak, any problem here?
No, sir.
Okay, next. So this we have already done. So there can be 2 modes, 3 modes, 5 modes, any number of modes. Or there can be a single mode. Highest number of frequency always is going to be mode. But if multiple numbers are repeated, multiple numbers are repeated or multiple things are repeated same number of time, then there will be multiple modes. Okay. So now there is one more concept we have already discussed. I think you know this concept. What is nominal data? So see the example of nominal data. Gender, male, female, other. 3 genders are there. Male, female, other. So that is nothing but nominal data. Hair black. Black, brown, blonde, red, other. So this is nominal data. What do you find? Religion, Christianity, Islam, Hinduism, Buddhism, other. Type of animal, dog, cat, animal, and other. So you see there is no order in this. These things are simply defining something. But there is no order. I cannot say that dog is bigger than cat or elephant or lion is bigger than elephant or other is bigger than lion. I cannot say that. Now religion, Christianity, Islam, Hinduism, Buddhism, so they are in a order. But I cannot say Islam is better than Christianity or bigger than Islam. I cannot say Hinduism is better than Islam or bigger than Islam. I cannot say Buddhism is better than Hinduism. They are just representing some religion. There is no order in this. But suppose my numbers are high, medium, low. Instead of this, if I say high, medium, low, then there is a order. Medium is higher than low and high is higher than medium. There is an order. So in nominal data, there is simple, defines a group. Nominal data simply defines a group and there is no order in that. You can put in any order. Best is to put in alphabetical order. No dispute. So Christian cannot say that I am first or I am second. Just put them in alphabetical order. Or there is no order. So you understood, right? What is nominal data, guys?
Yes.
And nominal data is always string data. No numbers in this, okay? Numbers will not be there. Only string type of data, male, female, other, hair color, black, brown, blonde, red, other. So like that. So you have nominal data. Now next we'll use this concept. Some important points. Mode is only descriptive measure for nominal data. So this kind of nominal data, we have only one measure for descriptive statistics. Descriptive statistics, we have only one measure, that is mode. For numbers, we have two, mean and median, right? And then range is also there, maximum, minimum, range, standard deviation, mean, mode, all these measures are there for numbers. Descriptive numbers, descriptive statistics, these are variables. But in case of nominal variables, mode is the only measure. Median is unaffected by extreme values. Median is unaffected by extreme values. If my definition of mode is how many times it is repeated, so it is not affected by extreme values. Mean and average is affected by extremely small or large values. We know that. In a systematic distributions, mean and medians are close together. Like we know that if distribution is symmetric, like we have studied in many classes, our normal distribution. So normal distribution, if you put a line in between normal distribution, there is a curve. And if you draw a line in between, left side and right side are similar, same. So mean, median and mode will fall in the same point. So if distribution is similar, your mean, median, mode will fall in the same point. If distribution is asymmetric, like your right tail is larger or left tail is larger, then you have mean, median, mode different, falling different. Okay, so now just once again revision here. Mean is nothing but add all the values divided by total number of values. Median, you know that, middle value. If odd, it is a middle value. If even numbers, then two middle values, you have to take the average. That is median. Mode, you know that now, most common value. Most common means most frequently repeated value is median. If then we know that mode can be more than one. Mean can be only one. Median will be only one. But mode can be multiple. If same number, if different things are repeated same number of time, that means mode can be multiple. That we have seen the example. So once again, if I show you, here in the second line, there are two modes, 5 and 6, because 5 is repeated 3 times and 6 also repeated 6 times. 8. So why 8 is not the mode, guys? Can anybody answer that question? Why 8 is not the mode here? In second row, why 8 is not the mode?
You got it 2 times.
Yeah, others are repeated 3 times. So that's why there are 2 modes here, 5 and 6. In the top one, in the first row 6 is repeated 3 times. So there is only one number which is highest repeated, highest number of time. So we have only one mode, 6 here. So now we have done mean, median, mode, expected value. So with these concepts, I will close, and this mean we have completed, median we have completed, mode we have completed, and expected value we have completed. So we have like covered quite like these are all basic concepts. Okay. So with this, I will close today's lecture, and next lecture we will learn all these things: range, quartile, variance, standard deviation. I'll again once again tell you how to calculate variance and standard. What couple of classes we have already discussed how to calculate variance and standard deviation. Then I'll tell you how to calculate skewness and kurtosis. That also, these are new concepts. I will introduce these concepts, and then I'll give you a formula also to see this. So with this, your statistics basics will be all strong. You will have a strong foundation in basics. If somebody asks you mean, median, expected value, you will not see here and there. You will know what it is. Okay. And all these concepts, they are all very commonly asked in all interviews. Or everywhere you should know all these concepts. So with this, you will know all these concepts. So let me check how many slides I have for this. So today I have finished 19, and we have little 40. I don't know how it will take 43. So we'll try to finish in next one lecture. We'll take one lecture little longer and finish this lecture in next lecture. So all these things, all see, if your asymmetric distribution here, this distribution is not symmetric, no? Right hand side tail is larger than left hand side. So your mean, median, mode, how they are distributed. Mode is in between, median in there, and then mean here. Then similarly, I have taken another case. See, this is right tailed. This is right tail, no? Right hand tail is longer. So like that, you have mode, median, and mean. You see the left tail. Left tail also, you have like this. So we'll study all of this. Okay. So next is going to be more interesting.